Hello everyone, welcome to lesson 8-8, volume and surface area of composite figures. We will continue to address the essential question, how do measurements help you describe real-world objects? And today we don't have any new vocabulary. So how does volume and surface area relate to the real world? Let's see. Kaylee and Miles are making a bat house for their backyard like the one shown. They need to determine the surface area to find how much wood they will need. Now here's the bat house, multiple houses and one where you can crawl underneath. Okay, I didn't really know this was a thing. Question 1. Look at the largest bat house right here. Right? What three-dimensional figures make up the bat house? So what three-dimensional figures? I see we could have the three-dimensional figure that makes it. I mean, on the side over here we have a bit of a rhombus. Okay, we have two parallel lines, one perpendicular and one slanted, if you want to say that. Or we could have a rectangular prism, right, but it has a slanted roof. And then what method, number 2, could you use to find the surface area of the bat house? What method? So if we have the bat house here, what method could we use to find the surface area? Oh, we identify all the dimensions, right? The length times the width times the height of each side. Now we know that this side is going to match the side on the back on the other side, and the front is going to match the side on the back. Okay, and we don't have anything underneath, but then we would just measure the roof on its own, the dimensions, and then add all of those areas. So we would do it by finding the sum of all the areas. Number 3, suppose you wanted to find the volume of the bat house. What method could you use? We could use the formula volume equals length times width times height, and that would tell us an approximate volume of this composite figure. So similar to how we were able to identify the area to composite figures, we can do the same for volume by deconstructing the composite figure. So the volume of a composite figure, a figure that's made of multiple different 3D shapes, can be found by decomposing the figure into solids whose volumes you know how to find. So rectangular prisms, triangular prisms, and so on. So you can see here that we have a composite figure, right? And it's three-dimensional. So we want to find the volume. But if you were to cut it into two, you can see that if we were to draw a line right there, I'll use a color that you can see better. If you were to draw a line right there, you can see that we have a rectangular prism, okay? And then we also have another rectangular prism. It's not quite a cube because the width is only 6 right there. So then you would find the volume to both of these shapes, and you add it up. So volume equals length times width times height. And then you replace the variables, you get 768. And then the other volume is 8 times 6 times 8. You see, 8 times 6 times 8, which is 384. Then the volume is adding that amount plus the 384 that you see right there, and it equals 1,152 cubic inches. Over here you can see that we have something that looks like a little bit like a birdhouse with the roof and the room. Well, we have two figures here, right? We have a cube because it's 8 by 8, which makes us perfect square, and then by 8, so it's a perfect cube, right? So it's 8 cubed, 8 to the power of 3, 8 times 8 times 8. And then we have a pyramid, don't we? We have a square base, right? And then times the height right here of a pyramid. Now remember, a pyramid is 1/3 of the entire cube, right? So as we've practiced before, we will do volume equals length times width times height. Volume equals 8 times 8 times 8, which is 512, right? So we have 512. And then for our pyramid, we find the area of our base. 8 times 8 is 64, times our height, which is 5. But we need 1/3 of 64. Remember, 1/3, because That's what a pyramid is. A volume of a pyramid is 1/3 of a full rectangular prism. So 8 times 8 is 64, right? For the area of our base. And we want 1/3 of 64 times 5, which is 106.7. So then we add the 2, 512 plus 106.7, and we get 618.7 cubic feet. Now we can try it on our own. We have a composite figure here. It looks like an end table, maybe a nightstand. And we can see that this dimension all the way from the bottom to the top is 9 centimeters. All the way across is 12 centimeters. The depth is 6 centimeters. And over here, just from here to the bottom to there, is 7 centimeters. That means if it's 7 to here and 9 all the way to the top, as we can see here, right? As we can see there, that means from 7 to 9, there's 2. So the width of this is 2. If I were to cut this into different figures, I have 1 by 6 by 7, and I would have the same here, 1 by 6 by 7, wouldn't I? Right, that's one way to cut it. I could just cut them into 3 pieces where I would make a line right there. So this is, and it would go like that, right? All the way there. This is piece 1, which is, this is piece 2, but it's the same one as 1, and then there's the third piece, right? Or you can just solve for this one right here and multiply it by 2, because this is 1 and 2, and then you add it to the top one. So if I were going to solve for this volume of piece number 3, I would go volume of 3, right? Is length times width times height, correct? I know that for that, the volume, I just made this name up, by the way, the volume of piece number 3 or figure number 3. It's a rectangular prism. I have, my dimension is, my length would be 12, right? It goes all the way across the top right there, you can see. My height, or my width, would be 6, right? And you can see that right there, right? And then my height, remember, it's the difference between 7 and 9, because 9 is all the way up, so it's 2. So my height would be 2. So I have 2 times 6 is 12, and 12 times 12. So the volume of 3 is 144 centimeters cubed. Okay, so I have the answer for this one. Now I'm going to solve for this one and double it, because I have 1 and 2 here. So now I have 6 by 1 is 6, and then 6 times 7 is 42. Okay, so volume of 1 and 2, right, is length times width times height times 2. The volume of 1 and 2 will be, length is, let's make the length 6. Our width is 1. Our width times 7. And then we have to double it, because there's 2 of them, right? Now, so we go 6 times 1 is 6, and then 6 times 7 is 42, and then 42 times 2 is 84. So volume of piece number 1 and piece number 2 is 84 centimeters cubed. Now I can go ahead and add the 2, so I can bring all the figures together. So I add 84 to 144. I would get 228. So I just added the 144 of the top part, and then the 2 side parts is 84. So 144 plus 84 is 228 centimeters cubed, not squared. Oops, squared is only area. We're looking for volume. And now for the second part of our lesson, surface area of composite figures. Okay, again, I believe we've done this already, where we've looked for the area of a composite figure. Here, for example, we have this shape, okay, this L shape, upside down L, and we know that we could break it up into 2 pieces, one long one and one side one. Oh, this is, I believe, is actually for the first shape that we had, the very first, this one right here. Okay, you can see that it's 16 by 8, right? 16 by 8, and then 16 across the top, 16 across the top, and it looks like we're cutting it right down So right there, like we did before. Okay, and now that's its surface area, so it's only a two-dimensional figure, right? We're just considering the two sides out. There are two of these, front and back, and then there's the side one. There's the little piece there. So we break it down into all the different surfaces. And you can see that we're doing area equals length times width right here, or length times width, plus length times width of 8 times 8. So we are accounting for this part as well, plus 8 times 8. You see that? Okay. So that gives us 128 plus 64 is 192. So that's only giving us the surface area for this side. Then this part is the back part. You see it's 6 wide and 16 down. So we solve for that. And then this part right here is the very front part. Okay. We might have also solved here 6 by 16, the part 6 by 16, the top part, not even the back part. So really all we're solving for is this piece, and this piece right there. Okay. And because we were able to solve for these pieces, then we just multiply them by 2, okay, and we get our final total. Example 4. Remember, for example 4, we had a 3D figure that looked like a little house with a roof, a pyramid on the top, and a cube for the bottom. Well, here it is as a surface. So so we have to figure out the surface area. We have length times width, and that'll give us that surface area. Okay. But how many figures do we have? We have 1, 2 on the side, 3 on the back, 4, and then the bottom is 5. Correct? So the surface area for that is 8 times 8 is, just for 1, is 64. But then the total surface area for this is there's 5 sides, as I just mentioned, so it's 5 times 64. And then we have to solve for the pyramid. For the pyramid, we have to solve, because it's surface area, we have to use the slant height. So right here, the slant height is 6.4. Remember that? Here it is, 6.4. Okay, by 8. So it's half the base times the height. So it's really 4. Instead of 8, we say 4 times 6.4. Okay, or you can do half 8, and then you have 4 of them. 1, 2, 3, 4. So you multiply that by 4, and you get your 422.4 square centimeters. But when you add it to the cube, okay, so you can see it all there. If you need more time to take a look at this, go ahead, pause the video, and you can look at the 3D figure and look at the two-dimensional surface area. Okay, and now for our example, our exercise, we have to find the surface area of the steps that are represented by the composite figure. So we have some steps here, right? And we want to just find the surface area, not the volume. So our surface area is going to consist of this piece 2 times. So this piece, and it's repeated again on the back, and it's this piece plus this part right here. Together, if you were to put them together, it would make this entire back part, right? And if you take this piece right here, right? You see this piece? Well, that piece is this and this made together. So you could double this one, okay? This one plus this one will be this one, or you could just simply double this one and it'll compensate for these two, okay? So let's work with it. I'm just going to go ahead and break it up into 2 parts. And I think the most obvious way to break it would be right down like that, wouldn't it? Okay, so that I have now part number 1 and part number 2. But now we're not, sorry, no, that won't work like that because we're not looking for volume. So I'm just going to undo that. But it will work for surface area, okay? So remember, as I mentioned, this panel over here, the 2 feet by 2 feet, right, is repeated twice because it'll be here as well. Okay, if we were to remove this from it, you would have a wall there, right? So let's find the surface area for this piece, and then we'll find the surface area for this piece, and then we'll add them both. So you can see here, I've written out the formula just for this one, where we're going to do 2 length times width, length, right, the length times the width, for the top and the bottom. We're going to do 2 of the height times the width, height times the width for this side and this side, and 2 length times height, this length times height, so the front panel and the back panel. That'll cover this one. Then we repeat it also for this one, where we do 2 by 1. Remember, because if this whole thing is 3 and this is 2, that means this must be 1, right? Because 3 and 3. So 1, so this would be 2 by 1, and then again, this one would be 1 by 2, and this one would be 1 by 1, okay? And we work with that. So we'll call this the cube 1 or shape 1 and this shape 2. So we have area of 1. Okay, and remember we are looking for the surface area, so let's put that S in there. Surface area of 1. Okay. So now we have to replace the variables, right? The length times the width for this one. Here's our length and here's our width, or you can call this length times width. Now what's our width? How far back does it go? How far back? Well, you can see that down here, right? Because it's the same. So our length is 3 and our width is 2 for this. And it will also be for this one. So when we replace the length right here, we put 3. When we replace the width, going backwards, we put the 2, right? And then we have to add, and we have to multiply that times 2, obviously, because we have the front and the back of it, right? And now we're going to add 2 height times width. Height, what's our height? You can see right there that it's 2, okay? And our width, again, is 2. You've got that number from here, because that's the same as here, 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 and here. Okay, it's all 2. So it's 2 by 2. So we go ahead and we write that down. Plus 2 what? 2 length times height. Now, the length times the height is going to give us the front panel and the back panel. The one that you can't see, it's because this front wall here is also on the back. So our length is 3 times, and then the height is 2. And there we have it. Now we solve for that. Remember, multiplication before addition, so we have to multiply all of these first inside the parentheses or the brackets, and then we multiply by 2. So 3 times 2 is 6, and then times 2 is 12. All I did was here was 3 times 2 is 6, and then you multiply that 6 times 2 and you get 12. Plus 2 times 2 is 4, times 2 is 8, plus 3 times 2 is 6, times 2 is 12, right? And now we have 20. When you add the 12 plus 8, sorry, I should keep my plus 12. And 20 plus 12 is 32. So there we have 32 feet squared is the first surface area for this one. Now we have to solve for the surface area of the second one. This one right here, right? So we have our surface area of the second shape. And again, we follow the same formula. 2 length times width plus 2 height times width plus 2 length times height, right? Because there's 2 of them in this shape. There's 2 of these, one on this side and one on the other. The front and the back has, and the top and the bottom also have the same area. So we go ahead and write that formula down. 2 length times width, as you can see here. 2 length times width, so length times width, 2 of those. And I see that this is 1 across. How do I get that number? That this from here to here is 1. Well, the whole thing is 3. Right? And up here is only 2. So it goes to 2 up to here. And to go from 2 to 3, I need 1 more. So this right here is 1. 1 times 2. You see, 1 times 2. So we'll do that. We have 2 times 1 times 2. Right? Plus 2. And what do we have? Width times height. 2 times 1 again. Times 2 times 1 plus 2 length times height. The front and the height is also 1. You can see because it tells us right there. So length is 1 times height. So it's 1 times 1. Pretty simple as 1. 1 times 1. Okay? Let's solve our surface area for our shape, our second shape. Let's do this. 2 times 1 is 2, times 2 is 4, plus Again, 2 times 1 is 2, times 2 is 4. And finally, 1 times 1 is 1, times 2 is 2. And we have 4 plus 4 is 8, plus 2 is 10. So our surface area for the shape number 2 is 10 feet squared. So here's our first one. Sorry, here's our second one, here's our first one. So when we put the two together, the two shapes together, we have 32 plus 10 equals 42 feet squared. Alright, I hope that made sense. It was a long process to get there, but we will practice this in class. This is how we will start class. Take a look at it, make sure that you feel comfortable. If you're not 100% sure how to do it, visit the examples that we did, 1 and 2 in the video, or down here, 3 and 4. Okay? This is how we will begin class. So see you then.